This lecture is about software testing in practice. Most companies' new hires are testers. Most testing work is manually testing the software system. Help from tools is limited. In many cases, testing is not performed by using systematic testing methods or techniques. It is not effective. There are conflicts of interest between testers and developers, and testers and management. Benefits of software testing are that software testing involves consciousness of the need for error-free software, ensures the more flagrant kinds of errors will be detected, improves software quality, adds a layer of quality assurance to inspection, walkthrough, and peer review, helps in data collection from root cause analysis and process improvement, provides a framework for applying SQA techniques, and use of systematic software testing is more effective than programmers' casual testing. Verification. Are we building the product right? Are the software development processes and procedures used to build the product correct? Validation. Are we building the right product? Does the product fit the requirements? Testing is a pragmatic approach to software quality assurance. Program correctness proof is a theoretical approach to SQA. White box testing generates test cases from the internal structure of the component under test. Test cases are generated through analysis of the source code. Basis path testing is a white box testing technique that tests the independent control paths or the basis paths of the component under test. Tested paths are if-then-else control statements, switch statements, loops, and sequential blocks. Flow graph test coverage criteria specifies the path coverage of the component under test. A weak criterion yields the lowest confidence in testing paths of the component under test, while the strongest criterion yields the highest confidence. The criteria ranging from the weakest to the strongest are node coverage, then edge coverage, basis path coverage, and the strongest criterion is all path coverage. Data flow testing focuses on the definition and use of selected program variables. Functional testing derives test cases from the requirements. Functional testing is referred to as black box testing because it refers to the component under test as a black box with an unknown internal architecture. Three commonly used black box techniques are equivalence partitioning, boundary value analysis, and cause-effect analysis. Equivalence partitioning divides the input and output domains into disjointed subsets and selects a test case from each subset. The test case is characteristic of the software related to the partition from which it was selected. Boundary value analysis derives test cases from input and output at the boundaries of the equivalence partitions. Boundary value analysis and equivalence partitioning complement each other. In cause-effect analysis, a decision tree is constructed to help generate test cases. The decision table shows the correspondence between input values and output values. The test cases are derived according to the rules in the decision table.